Hey there, IB Computer Science students. So today we're going to be talking about array lists. You just finished up learning about arrays, and now we're going to learn about array lists, which are a class very similar to arrays. There we go. Okay, so an array list. Come on, there we go. Array list is a class that houses an array. That's not too exciting, but remember the array itself, what we talked about last time, that's not a class, that's a data type. And that can store, you can have an array of objects, you can have an array of primitive types, all sorts of things. Similar, an array list can store any type as well. Just like in arrays, everything starts at position 0. Well, just like everything in computer science, we start with a position 0. So let's back up. Remember, talking about an array, it looked like this. We had int, square brackets, our name of our array equals a new int, and then we would give the size of the thing here. And remember, last time we talked about that this size 10 is fixed. So the array named nums is never going to be size 11. It's never going to be size 7. It's 10 until the program ends. And if you change it, you'd have to go back in and recompile things. So that's how an array is: fixed size, fixed type. We can only, now we've declared it to be integers, we can only store integers in there for the time of the program. An array list is different. So an array list is a class built into the Java API. We'll take a look at that in a second. And it is a reference variable used to store the location of an object, and that object is going to be the array itself. You create it, let's take a look here, we create it by doing this: array list equals a new array list. Notice at this point in time, we've said nothing about how big it is. We didn't say that there's going to be 10 items in here. We didn't even say whether we're going to store strings or integers or doubles in this array list. We've just said, hey, create a new array list. And if you want to kind of visualize it, it is going to have a memory location, let's say 0x213, and some empty brackets in there because there's nothing in there yet. So let's proceed on. So let's say we do this. Now, notice here, this is a fine point that we're going to get to in week 8. Next week, I think. We're going to talk about why it's list over here and why it's array list over here. What you want to know right now is array list is a class and list is an interface, and it's totally okay to have list equals to array list. You will understand after week 8, maybe into week 9, why this is. But right now, just kind of go with it if you're okay with for now. So that's a subtle point. But what we really want to be looking at here is the use of add. So here we've created our list, and now we're adding stuff to it. .add. We have our name, our variable name, and we do ray.add. We add the string hello. Ray.add, we add another string woot, and ray.add, we add another string contests. Now there's three things in that array. Their location 0, 1, and 2. And here that's just printing out different characters. So here we do array.get, get the thing at location 0, and get the first character out of that. Well, that's the H from hello. So that's the first character in there. Then it says get something at array location 2, and that's the C from contests. So, I mean, maybe this isn't the best example, but we'll look at the get stuff later. But anyway, the big point from this slide, adding. .add is our function that we want to go with. Great. Okay, so now, here's just another example of what I showed you. Keep in mind, guys, when you start your homework assignments and you're thinking, oh, I need to use an array list and I don't know how to do that. Remember, this slideshow is available for you all the time, and you can come back and find examples of nearly everything that you want to do within your assignments somewhere within these slideshows. So it might be a good idea to have this open off to the side, have your IntelliJ window open, and be kind of moving back and forth so that you can have these examples right at your fingertips, as it were. All right, array lists. Generic ones. So it used to be, and for us, who cares because we're working in present day, but it used to be that you couldn't specify which type of data to store in an array list. But now in Java 5, even though we're well past Java 5, you can. So the big excitement here is that now we can say, hey, I'm going to create an array list of strings, or I'm going to create an array list of doubles. And that just helps things out, so you can be very specific about what you want to be adding to your array list. And you can do array lists of mixed types as well if you don't do this. And here's long, and here's array lists of some sort of IT type. So let's take a look at how this is going to look now. Our example that we had before, we create a list of type strings. Notice these very nice angle brackets here, the less than sign, the greater than sign there. And again, we have to say on the other side of the equation that it's a string as well before we do our empty brackets. What you remember from last week, what you remember from last week is that we are calling a constructor here. This is a new array list constructor. It's the default constructor because we're not putting anything in there, but that's carving out that space in memory for our array list to look at. So now we have this array stores string references. Okay, and here's another example of that sort of business there. And an example of storing long values instead. So one of the nice things is the array list comes with a whole bunch of references that you can go along with it, or a whole bunch of methods, sorry, that you can use on it. We have add an item, defaulting to adding to the item, end of the list. You can add at a particular spot. You can set a particular spot. You can get a spot in the array list. You can figure out how big it is. You can remove an item, and you can clear. So we haven't made this distinction yet, but the array list is something that can grow in size. You can start off with an empty array list, and you can add 100 items to it through the course of your program, no problem. Or you can add 10, or you can add 50, or you can add 100 and then shrink it back down to 50. So there's no fixed size, unlike where we're dealing with the array itself, where we had to say, no, this thing's going to be a size 10 or 20. So that's one of the nice things. So add will just keep adding on to your array list until you run out of memory on your computer, I suppose. There's got to be some upper limit but there isn't one that's defined by you. So here are some examples of adding different things to the array list. So here we're adding IT and IS, then we add an A, then we add a 1. So you can see how that shakes itself out. So here, the first one, we have our empty array. So at this point, it's just IT. At this point, add adds to the end, so it's IT, comma, IS. And then notice we start to use an index. So we're going to add at location 0 an A. So that scoots everything over. So we have A, and then comma IT, and comma IS. Now we're adding at location 1, and that's going to scoot everything over as well. So we have A, comma, OLIE, comma, IT, and then comma IS. And then you print out the whole thing. So this is what it looks like. That's how it evolves over time. Adding it, since it's empty, it adds it to the first location. Adding it again adds it to the back. Adding with an index adds it at that index location, which is 0, happens to be the front of the array, and then adding it at 1 sticks it in location 1 and then scoots everything else over. There's more examples here, adding another example on there. And then here's an example of set, and set is different than add in that it changes the values in that array list. So here we have 23, I'm just going to write in purple as things go, so we have 23, then comma 11. Now take a note, we do a set here. That's not scooting things over, that's replacing the 23 with a 66. So we have 66, comma 11 in our array. Now we add a 53 onto the ends, so we have 66, comma 11, then a 53. Now we're going to set location 1 to be 93. Let me draw this over here. 66, comma 93, comma 53. Whoa. And then adding 22 just adds that onto the end of the array, and that's our final array sequence. So this one's looking at set versus add and how those two things are different. And the definition, set at a spot, a particular item, replaces the reference in that spot with the new item. Okay, carrying on. And you can imagine, so here's another example using set. Get is probably going to be about the opposite of set, so returning that value so that you can access it. Here's the case we're returning it so that we can print it out. Array.get, oops, I need to do that. Array.get 0, what did I do now? Oh, sorry. Array.get 0 is just getting the value at location 0. And here's another example of using get within a for loop, so you're getting every item in that array. Okay, processing a list using loops. Remember in the last lecture we talked about the two types of loop. Here's your traditional one where you have an index and you started off at 0 and you go for the size of the array and you add 1 each time and that sort of thing, and you print out the values. You can also use the newer for loop that has the for int num in array, and it goes through each item in there, printing it out one at a time. This way you don't have to deal with the size and you don't have to deal with an index. It does all that behind the scenes for you. So that's pretty nice. Okay, the remove methods. Excuse me. So here we have a different sort of method here. So let's do some writing here. So you can also remove an item from a list. So let's build up our list. So we add A in that first one, then we have A comma B in this one, then we remove the item at location 0. So that collapses the list down, and then we just have a B. And that B is shifted over, and that B is now at location 0. So that's location 0, put a little 0 there. A was at location 0, we removed the item at location 0, and B popped in. And then we add a C, so we have B comma C, and then we have B comma C comma D because we added, and then we remove the item 0 again, so that B goes away, so we're just with C comma D, then we print the whole thing out, and voila, our final list is C comma D. So remove is very handy. Keeping in mind, if we're going through that, the size of the array is changing all the time. Here we've got a size 1, a size 2, we're back to a size 1, then a 2, then a 3, then a 2. So size is changing as we add and remove. Remember, that's very different than with the standard array that we were looking at in the last lecture where the size is fixed. So this is really pretty great because it's nice to be able to remove things and add them to the list and have the size change according. It's quite nice for us. Okay, so there's remove example, another remove example. You can removing multiple items. So that is, you know, this is the general framework. So let's say you want to remove something that matches. You have a list of numbers and you want to remove all the zeros from that list, for example. So as you do that, here's the general algorithm you want to follow. You want to figure out your list size minus 1. Then you're going to say while your spot is greater than or equal to 0, because you don't want to remove anything on a list that is size 0, because that's going to throw an error for you. Then you're going to say, hey, does this item match what I'm looking for? You're looking at things one at a time through the array. If so, remove that item, but you're going to want to subtract 1 from spot, because that list, you want to take into effect that list is shrinking. So let's take a look at how that actually looks in code. Spot is list size minus 1, while spot is greater than or equal to 0. If list.spot equals value, remove spot and subtract 1 down. So this is going to check every item within that list, making sure not to double check things, and also making sure not to, if you remove the whole thing, it's going to stop before you hit 0. Here's another example. There's a function method in Array called clear, which deletes everything. And you can use arrays with classes that you have created. And I am going to just go point out briefly that you can do this. Yeah, because this will be handy later on. So let's say we've created a class named creature. You can set up, notice how there's creature in these angled brackets here, and creature is our defined class, and you add it just like you would add strings or anything like that to it. So here you can see we have an array, and it's an array of our creatures. And that is all I'm going to cover for today. You can look through the rest of the slides, but those are the big points.